I'm Nader Salessi, founder CEO of NGD Systems. Just a quick introduction of myself. I've been in the high-tech industry for quite some time. In the last 15 years or 15 plus years, I've been involved heavily in the solid-state drive. So I started the division in a company that used to be called STEC, STEC, to define solid-state drive from 2003. And we formed a team at SSD, at the STEC to define enterprise class SSDs from 2003 2004. And over a period of 7 years, we grew the business to more than $360 million revenue, and with many generations of the product that became known in the industry as the enterprise class SSDs. I also worked at the Western Digital from 2011 for a couple of years, and then doing again enterprise class SSDs for the top of the pyramid from the SSD, the tiers of the type of SSDs that we were working on at that time. In 2013, we identified a unique need in the marketplace, and that's how we left the company and we started the NGD in 2013. So let me have my team members also to introduce themselves. So.
Hi, I hope it's on. So my name is Vladimir Alves. I'm one of the co-founders of the company together with Richard Mataya. I come from a background of academia and research, and I'm not going to bore you guys with the details of my past life, but I met Nader when I left that side of the world to join a startup in Irvine, and that's where we first met back in 2001. And since then, we've been kind of working together in different companies, and my focus has been mainly in the computer architecture, controller side, the ASIC that are the foundation of the SSD controller, of the SSD technology itself. That's it. Thank you.
Go ahead, click it. And last but not least, I'm Scott Shadley. I'm the VP of Marketing. So I joined these guys at STEC back in 2007. I went back to my alma mater at Micron for a second stint, so did a repeat offense there. Decided that it worked really well repeating myself, so I figured these guys came from STEC. I knew them pretty well. Known them since they founded the company in 2013, and finally this year decided to make the leap, and so now I'm a repeat offender, if you will, with these guys now here at NGD. We originally had the company was called Next Gen Data, NXGN Data. When they changed it to NGD and we renamed the company Nerds, Geeks, and Dorks, I had no choice but to come join the team.
Yeah.
So,
Kidding.
Well,
you
there
can
were
see
those guys in Colorado that were next-gen storage.
Yeah, and they had their ups and downs and swings and whatever else. So quite the rest of the team, all of us have some synergies in working together in the past. So from a leadership team perspective, we've all worked in various different organizations at different places, but at the same time, we all came back, and it makes a very nice leadership team, let alone the amazing engineering talent behind the scenes actually building the products. So I'm going to hand it back to Nader, and he's going to give you a little bit more on where we come from and why we're here.
Yep. So I'm really lucky to have around me all the experts in their domain expertise, the technical folks in the team, the engineering who are doing the development and coding. Collectively, they have more than 300 man-years of solid-state drive. So what we are working on, it's actually when we were looking at starting the NGD, we saw a wave of new requests coming in, especially from the large mega data centers. The capacity point was increasing, and they were looking at all the storage used to be all about the higher IOPS or faster. That was everything that everybody was talking about. Other than increasing the capacity, there was no other thing, but those measuring stick was the old-fashioned way for the people to measure it as what's the IOPS, because they were maxing out. So we were looking at the storage, what other things that make sense to do it, especially when the capacity increases. And that's how we came up with the new concept of bringing more intelligence into the drive So other than doing the write, read, and erase, it can do some additional function, which we will talk about it later. And obviously, we have heard it certainly in the past few years, more and more the need for doing the near data processing. The demand is becoming more and more from all aspects. And again, when we go into the more detail of the use cases, we can see what are the benefits by bringing the intelligence into the storage device. So looking at one of the largest data center in the world, so specifically this example is from Microsoft Azure use case. For their new servers, they are increasing the number of SSDs per server. They are trying to reduce the power footprint, going toward they have some use case or some platform that is single CPU, 16 lanes of PCIe. The other thing, because of the demand of the storage, they are increasing the capacity of each drive also. That in the old days, it used to be a few hundred gigabytes, maybe 1 terabyte or 2 terabytes. Now they are looking at 8 terabytes for each drive or higher for the next generation. And the number of drives that used to be 12, 24, it's getting to more than 64 drives per server. So that puts a new set of challenge because the access to the data on the media, by far, it's a lot more compared to the access to the CPU or the compute. There is a bandwidth mismatch that they are looking at it that is more than 50x between access to the data on the media versus access to the data for the compute. Similar requirement is happening at the edge of the network. As it moves from cloud data center to the fog, massive amount of data is being produced on the edge, obviously. And a lot of people are trying to make sense out of those data. So all the AI algorithms are hungry for accessing the data to make sense out of it. So the old-fashioned way doesn't work. So moving the data to the cloud to do the compute is just not practical. So our vision is creating a new paradigm shift by moving the compute to the data. And our value proposition is to provide a solution that we focus a lot on energy efficiency, on the lowest watt per terabyte, driving the cost to be the lowest dollar per gigabyte based on technology as well as our business model, plus the compute, which we refer to it as in situ processing, that is capable of running AI, machine learning, computer vision for the actual applications. So we are not using AI to do the flash management. We are talking about running the AI on the data to make sense for the users. So it's a new way, again, by moving the compute to the storage. We also looked at it that we cannot create a new interface that would take many, many years to be adopted. We want it to be simple, useful for the users to adopt it as fast as possible. So we use the PCIe NVMe as a standard protocol with no driver. And we use a mechanism to move through the NVMe and bring the computation inside for the application inside. And of course, inside of the SSD controller that we have designed, we have dedicated resources for the computation, which is separate from the real-time CPU that we use for the flash management and all the protocol, that NVMe protocol that needs to handle. So the application processors, we refer to it, those are reserved just for the user applications, which we will go into more detail of it as we go into the use cases.
Is that a complete dedicated processor or dedicated cores?
It's a dedicated cores inside of our controller. So we have a quad-core A53 64-bit application processor with its own resources, access to the DDR, locally all within the drive. So when it needs to access the data from the flash, it doesn't need to go to the host. The host does not get involved at all.